Hello and welcome to today's webcast titled How GE Vernova's Monitoring and Diagnostics Center Scaled APM to More Than 1,000 Power Plants. I'm Aaron Larson, Executive Editor of Power Magazine. I'll be moderating today's program, during which we'll hear from Ben Myers, Global Monitoring and Diagnostics Leader with GE Vernova Gas Power, and Rahul Chadha, Vice President of Technology with GE Vernova Software. The presentation is expected to last about 30 to 35 minutes and will be followed by a Q&A session. Before we get started, I'll run through a few housekeeping items. In the webinar platform, you should see a chat area and a Q&A area. If you are experiencing any technical difficulty, you can ask for help using the chat function, and our production staff will assist you. To submit questions for our speakers, please enter those in the Q&A section rather than in the chat area. You can enter questions at any time during the presentation, and we'll answer as many as possible at the end of the program. Any that we don't get to during the live session will be answered via email after the webinar. Today's presentation will be archived on our server for up to a year, and future viewing will remain free of charge. You can use the same URL to reach the archived program as you did to reach the live program. PowerPoint slides will also be available upon request. A certificate of completion for professional development hours will be sent via email to every registered participant who attends. Before we begin, I'd like to thank GE Vernova for underwriting today's program. The company's generosity allows everyone to attend the presentation at no cost. And with that, Ben and Rahul, as the experts, can you show us what's under the hood?
Thank you so much, Aaron. Good morning, good evening, good afternoon, everyone. Really excited and honored to be at this stage with all of you and representing our APM with Monitoring and Diagnostic. Switching on to the next slide, I do want to start with who we are, Vernova. This is our new name, GE Vernova. You'll see us as a ticker symbol on 2nd of April. We are a conglomerate of multiple businesses, 12 businesses in specific, 3 segments. We divide ourselves into power business, which is your first line on the top of the chart, steam power, gas power, nuclear, hydro. Ben Myers, my colleague, is from the gas power business. Then we have our renewables business, which constitutes from onshore, offshore, and LM wind. And then we have the electrification business, which is grid solutions, power conversion, and the software business. We just changed our name. Sorry, we have not updated our slide yet, but we are GE Vernova Software, who I am part of. Team, I do want to start with a very high-level view of what we are going to be presenting today and showing and telling as well. This is our flagship software, Asset Performance Management, APM, which is positioned to help all the heavy-duty industrial segment customers with the energy transition challenge that we all face. We do have several modules. Each blob here is a module within the software. The one that we'll be deep diving in today, which Ben uses a whole lot, is around reliability and reliability plus, which is basically condition monitoring and predictive monitoring software. We do have a module for emissions and generations management. Definitely promise you to come back and discuss a lot more about that, but that's not our focus area. Today, our focus is going to be around APM and reliability plus conversation. With that, I pass it on to my colleague, Ben.
Thanks, Rahul, and good day, everybody. So what I want to speak to is the journey that we've been on here at GE Vernova Gas Power in terms of being able to deliver engineering insights at scale using digital technology. And we've been at this over 25 years. The very earliest days with the F-class machines was really focused around just a few failure modes that the business was intent on understanding. This was as simple as a modem, an Oracle database, all very manual. Think of the dial-up kind of days and kind of the constraints that we had there. As the business grew and the F-class fleet grew, tons of growth in this space. We actually moved our monitoring from Schenectady, New York to Atlanta. Mr. Chadha, Rahul, was involved with that move years ago, and it's grown ever since. Many of you may have visited us in Atlanta in our monitoring center or one of our other monitoring centers around the world. Over the last 20 or so years, we've followed the GE fleet in terms of its growth, its expansion into newer and more sophisticated technologies like the HA gas turbines, but also expanded into other centerline types of equipment, steam, gen, aeroderivative, other OEM machines, and beyond the centerline equipment all the way to balance of plant, just looking to look at ways that we can kind of accelerate the value creation for plant operators through these insights. About 2 years ago, we migrated from very much homegrown systems for monitoring to our software team's APM solution. So we went from centralized on-prem data center solutions that were fully managed by GE to cloud-based solution, full web interfaces for how the team interacts and is involved in collecting, monitoring these machines today. So with that, really, like, how do we do this and what are we really doing? So again, it's engineering insights at scale. And what I mean by that is we're developing analytics that do prediction and diagnostics of these machines and their failure modes, really focused around the power plant and within the fence. And what this means is over 1,000 sites monitored, over 6,000 machines and assets that we connect to today. And we're streaming over 15 billion data points every day. Some machines may have up to 200 analytics. And to orchestrate these analytics that run between 5 minutes and once a day, it means over 1 million analytic runs each and every day. But we do this with a team in total of 200 engineers, and the monitoring consists of only about 40 engineers. And so to do this, you need very efficient technology as kind of our underlying platform. And that's what we really want to speak to in terms of how we've achieved this. So, but with that, one thing I want to emphasize is in order to do this at scale, it's meant influencing what these products and underlying technologies look like. We have needs that really stress test these types of systems. And so we're always looking to kind of continuously improve. And I'll talk through some of our processes that we're using these systems and point out some of these areas where we continually look for improvements. So general construction of our architecture for how we do monitoring. And this is not unlike monitoring of things that you have in your personal life as well. You know, connecting into the control systems. We're always focused around security, and it is our number one. And so ensuring that we have the right levels of defense and multiple levels of defense in place to secure your data as it's transferred and secure your systems as we're connecting into these plants. We're streaming this data to the cloud, and that's where we're both collecting and storing data, but we're also using the cloud for all our analytics operations. So we're orchestrating these million-plus analytic runs in the cloud. And what I mean by orchestration is this is knowing exactly what analytic needs to run exactly when using what data for a given serial number. And so tons of back-end support and platform that's needed just to set up all of that. And we've set that up in an automated fashion, so it's seamless. And it's seamless not only to run every day, it's seamless in terms of adding additional assets that we're doing every day, every week. Where this all comes together, though, is the user interface. And this is really kind of common platform across the software team's APM product in terms of how we do visualization. And what this ultimately looks like for the team is the monitoring of all these power plants. So each dot represents a power plant across the globe that we're monitoring. And again, gigawatts of power. So we're at the moment over 179 gigawatts online that we're monitoring. And what this also allows us to do is respond quickly when a plant has an anomaly. So services that we offer include not only the monitoring and diagnostics with predictive analytics, but also trip type support. So a unit trips online, we see that within seconds and are able to respond with our engineers connecting with the site and being able to have dialogue with each operation room. And what makes that dialogue very rich are two things. It's the data that we're able to stream from the machine, from the controller, and also the standard work that we've built around many years of these trips across a fleet of machines. And so a thing I would emphasize with respect to what APM's allowing us to do is workflow these kind of activities. It allows us to workflow not only the analytics when they fire and say, hey, there's an anomaly that we should check out as an engineer. They also allow us to visualize immediately that data set that's associated with that anomaly. It collects all the information around the asset, so we understand the context, not only from the operational data standpoint, but also from the asset. And then we're able to do this, with respect to trips, tens of thousands of times a year. And with respect to analytical alerts, it's over 40,000 alerts that we receive and our engineers process every year. The really interesting aspect of this is being able to not only take that, but do it at a very centralized location. So we can take best practices from each individual site and each plant that we learn from and scale them across the entire fleet, all through this kind of central team, but also centralized in terms of orchestration of this workflow. The other aspect of it, though, is we can get down to kind of the customized level, and where we need to do something bespoke or custom for unique situation around a plant or an asset, we're able to tailor instructions for the team and analytics for that specific asset. So it's fleet level kind of insights that we're able to provide, but it's also very customized to individual machines and their needs where that's needed. And just an example of where we're doing this today, and just wanted to give something very relatable. This is gas turbine combustion system. We're monitoring effectively the sound acoustics or the pressure wave that's created with the combustion. And at what we'd call low dynamics or relatively low frequencies, the combustion is indicating that it's becoming unstable. So we call this a potential lean blowout situation. And what the team's really trying to do is not replicate what the operators are doing, but supplement what the operators may have challenges to see, or it may be impossible or very, very difficult. So in this situation, it may be a subtle shift in tones or these dynamics that the analytics able to pick up. And of course, we don't have engineers watching traces of data go across the screen. It's the analytics that are able to watch 1,000 different sites all at once and do this. And this really kind of amplifies the effectiveness of the engineering team that I work with every day. The other aspect of this is it's really difficult when you're looking at control room HMI type screens, and you may see a shift. You may not see a subtle shift in something that's occurring with the operability of the machine. What our analytics are capable of doing is look at 3 things occurring at once. It's a very subtle change in 3 different things that helps you triangulate what the failure mode may be and that there is in fact a problem. Examples like this are, if you were to see a very slight change in vibration on a gas turbine or a steam turbine rotor, and then associate that with the performance changing in the machine. And subtle changes of those things happening simultaneously indicate that you may have a mass loss within the rotating steam path or, say, compressor section of a gas turbine. And that's really, really difficult to see with the human eye. It's these triangulations that these analytics are capable of doing that makes this really powerful, as well as the physics that you can bake in with, effectively what we would call a digital twin. And of course, having designed these turbines, we're designing around physics, running analysis on components and at system levels. We're able to take those analysis models and run them simultaneously as the machine's running, and create kind of that digital twin of how the machine should be operating and compare how it is actually operating to see anomalies. And so with that, I'll hand it over to Rahul.
Very impressive, Ben. Thank you very much. Team, what I do want to share further on is the analytics that just Ben touched upon, blueprints, he talked about those. These are, there are two models in our APM software. One is with our journey so far, we have package of analytics that we can come bring it to your door. We call it Predictivity Monitoring Analytics Package. Smart Signal is a very industry known name, which runs and has a lot of analytics blueprints already developed for different kind of machines. Another model is, which is bring your own analytics. A lot of our colleagues, a lot of our customers, even Ben, they have been developing analytics. Gas Power has been developing analytics for the last 20 years. So they have analytics somehow written in Fortran that needs to be executed. There are analytics that are written in latest and the greatest LLM models or Python or Java. And the software does allow you to bring your own packages, deploy, and use the production workflows to get the insights. We do have many analytics packages under the hood, technologies wise. There are image analytics. Definitely, there's a lot of physics based analytics. There is applied statistics. There is machine learning. We have several algorithms that different of our customers are using to bring the insights on what they are looking for in specific. Here is a view of a quick view of our digital twin blueprints. This is primarily based on, I mentioned Smart Signal, which is out of the back predictivity monitoring package. We have 2+ million twins. These are different kind of equipments. These are different kind of make and model. This is OEM agnostic. We can monitor, for example, heavy duty gas turbines from all our OEMs that are across the world, including GE machines. Similarly, there is a number of assets, almost 7,000 assets now, a little older slide, it says 6,500, that are monitored by our IMS team, a service that we provide to ensure that when customers are starting the journey, they can lean on or get trained by experts who have done this for years, and then we pass it on to them. Some of the benefits are on the lower side. Cumulative benefit of $1.6 billion. This is available on our website by industry. You'll see industries like definitely power generation, oil and gas, chemical, aerospace, food and beverage. All of these technologies across applies wherever there's a asset-heavy industry, and a very approximate model on number of catches per week. With that, I do want to jump into the software itself, because I know you all are very excited to see how it looks like. So Ben, perhaps you start with your view and then I bring it back with the platform view.
So my view in terms of the software?
Yes.
Sure. Go back to the map. I'm not going to deep dive through all the aspects of APM because it's quite comprehensive in what the team does, but I'll maybe walk you through a real world example of what how the team would operate. And what we get excited about is just some of the integrations that the tool does, not only in addition to what's built in. So, for example, talk to the lean blowout on a gas turbine. What that's going to do is generate an alert for our engineer. And what we have set up is multiple tiers of engineers supporting this. And we use a kind of a frontline team to accept the alert in the workflow in APM, and then begin to triage it. And they have standard work to understand, is this something that is real, or this is potentially an anomaly associated with just a fluctuation of environmental conditions? It's okay. They also have a choice as to whether or not they need to pass it on for more in-depth review. So, I mean, sitting in Vernova Gas Power, I've got my team of a dozen people working on a front line. I've got 30 plus additional engineers that can support them with more in-depth review. And I've got 4,000 more engineers supporting us that are designing and helping maintain these power plants every day. And so what we do to escalate this across kind of that ecosystem of engineers is we then integrate our APM solution and the workflow with a ServiceNow platform that we use across engineering for kind of task management. And so this allows us to go between the team that's dedicated around monitoring, focused in APM, into the platform where the other engineers that may support or other personnel across the business may support do their business every day. And this is really powerful for us in terms of not having to swivel chair between tools in terms of understanding where you do your work. And as I mentioned, as we do this, it all links back to an APM case. And that case contains all the details on the asset, the situation, the trend data that's available behind that. And maybe, Rahul, as you jump into this, I don't know if you have a case or any sort of trend data. I can pull that up if the team would like to see that.
That would be very nice. And Ben, while you're pulling that, if you can also show an integration, perhaps the one that you're using is ServiceNow, and we can come back to that. So while Ben pulls that, there's going to be a little flicker on the screen because now I'm going to share my screen to show you under the hood how that works a little bit, the secret sauce. Please let me know when you guys can see my screen.
Got it.
Yep. So team, what you see here is a quick view of our platform in last one day. As you can see, these are very, very big numbers. I understand. Somebody asked what's the frequency of the data. Guys, we are ingesting almost 1.9 trillion data points every single day. So I've just taken a one-day view, as you can see. This platform consists of several technologies under the hood that functions in tandem, real time, ingesting all those data points. It's a online storage of almost 400 gigabytes when you talk about on a daily ingestion side. And this is constituted of 21 million tags, sensors we are streaming from across the globe. Now, one of the heaviest usage is definitely Ben's usage, gas power usage, which I'll come to. This is my entire system in a view, which is running in our US West POP. So APM hosted in two POPs today, one in Americas, one in Europe. This is all my 151 tenants, production tenants, or 152 today, that are actually connected live and are using. MND is one of our biggest tenant, definitely one of our biggest users as well. But we do have other industrial giants from power gen, as well as oil and gas and chemical industries, as I was mentioning earlier, who are using the same capabilities. Now, from this big view, I do want to jump into a little bit of a MND view that you have been seeing from us. If I can figure that out quickly, let me just switch screens. Right here, share. Now, what this is a very specific from that 152 tenants to exactly one tenant. Large of data points, but where I want to start is, again, Ben mentioned 13 billion points. Ben, last day you ingested 45 billion points. So that's your ingestion. It goes up and down. It also depends on the number of generating units. Every green dot on the map that Ben was sharing is a generating unit. We do have a lot of standby units. On standby units, the data ingestion is a little less, and generating units, it is a little bit more. So it fluctuates. Definitely the number of queries that are fired, 107 million queries, or 107 million, you're exactly right. Out of that, a lot of it is automated systems that are making analysis, analytics packages that we talked about. But all of this data is used across the globe by all of Vernova gas power engineers, whether they are using the data for monitoring or they are doing for their analysis, working with the customers, or internally, we are using it for our NPI development for our next gen machines. A lot of this data gets used by that. So that many number of analysis that are being run. So as you can see, a large usage, large number of packages, and it takes an army to keep it as well. Where we want to help our customers is to accelerate that journey and not go through the learning curve that we have gone through. All of this comes as a package for your APM SaaS model, APM on-prem model as well. And that's how we partner with our customers in accelerating that journey. With that, Ben, I will pass it on to you, and then we'll get into the Q&A.
Yeah, I'll jump back into APM real quick here. And so apologize about the glitch, but this will just take a minute. So again, just quickly, this is a view that one of the engineers might receive in terms of the alert that's been fired respect to, this is again kind of a combustion issue. And what they quickly go and do is they click into the associated trends with this and also have built within this system their standard work. So they're able to go and look at the trends and see that real-time data. They can manipulate this to see different windows, but this is the standard window we've determined for this particular issue. And then what they may do is go and create a case where they're going to kind of close this out. And this, again, is our mechanism to either escalate into deeper paths of engineering, or it's to close out the case with notes that may get reflected back to site. And what that looks like is a button click in order to open up a ServiceNow case that includes not only kind of the details around the alarm that occurred, but also details that include kind of around the machines and so on. So this is something that I just want to emphasize in terms of what we're able to do with respect to integrations. How my business process works is that we are communicating to you all as operators what we would recommend in terms of solutions. What gets really interesting with the APM product that doesn't fit my process, because I'm not operating the plants, is being able to not only integrate this with the workflows that we use in terms of support for engineering or diagnosing an issue, but the workflows that you may use for doing your actual maintenance, like an SAP or a Maximo system. And that gets really powerful in terms of closing the loop between, we found this anomaly, we work through and troubleshoot, and we say, it's, we recommend to go do this as an engineering team. We'd suggest change out this valve, let's say, and then you put that in Maximo and you can kind of close the loop on, was that the effective solution? And this is the whole kind of constant learning and continuous improvement path that you perform with these analytics.
Very well said. Thank you, Ben. And with that, I think we are ready to move to Q&A session.
All right. Thank you, gentlemen. That was a great presentation, a lot of information provided there. I appreciate you taking the time to explain all that to us. Also, I'd like to point out to attendees that there are 4 items loaded in the webinar platform under the Handouts tab. So I'd like to make sure that you go in and access those. You can download them and do that before you exit the platform today so that you get that additional information. So again, that's under the Handouts tab, which is up in the same area that the Q&A and chat functions are. And again, there's 4 items in there that you can access. During the course of the presentation, we've had a number of questions come in, and I want to encourage attendees, there's still time to ask your question. Just enter those under the Q&A tab, and we'll get to them as we progress through the Q&A session. Any questions that we don't get to, due to time constraints, will be answered individually following the presentation via email. So again, starting with some of the questions that have come in, first on the list, what are the data limitations? Number of points, sample frequency? Does data collection require direct Ethernet connection to a sensor or computer, or can data be collected via remote cellular connections? A lot of questions in there. Can you start with the data limitations as far as number of points and sample frequency?
Very good. And I will take that question, and then please jump in as you have large data sources as well. Yeah, very good question. I guess the engineer or the gentleman or the lady who's asking this question, they have lived through a very complex ecosystem of IoT. So data ingestion, as I showed you just a little bit earlier, we have a large data ingestion platform, and we do understand that we have a large frequency data sets or maybe 1 second data sets. So the example that Ben was referring to, the lean blowout, is coming from a 64 kilohertz dynamics monitoring system that is calculating FFTs and is generating a large amount of those data sets. So we collect those data sets in batches, and we transfer them to the online system where we run those analysis. Now, part of the FFT analysis is also a 1 second data set that we can put into the real-time monitoring system that can generate alerts and insights that people can react to. Those data sets are continuous data sets that are being ingested. There is no limitation. Yes, we charge by the drink, so it's not that it's all free. As you consume more, you use more. And then in terms of what kind of connectivity models we have using, I can tell you as an engineer, what changed things for us was that Windows 95 modem that used to make those screeching noises. We still have those modems in some places, by the way. The world evolves, but it doesn't evolve similarly everywhere. So we have array of connectivity devices. Security is a given thing for us, so we have models for each of those. But going back to what kind of technologies we are using as latest as fibers in some cases, and we do have some modem connections that are still trailing, and we're collecting data sets from that. As you can imagine, the data throughput and data speed will be a little different from those two connectivities, but we do have a robust method of just not managing and making sure data is captured, but using the tools that are built into our software to managing the health of these data quality and data connectivity as well. Ben, if you may want to add something.
Yeah, and maybe I'll touch on kind of the question around the sensors and how we connect, because there's just a plethora of what that looks like, and it continues to evolve with more and more innovation for sensor technologies. Often these sensor systems are coming back through, like what Rahul mentioned, the combustion dynamics monitoring. It's coming back through a centralized controller, and we're able to connect with those. Most often the easiest platforms to connect to are historian type devices. In the application that my team specifically does, we apply effectively a historian on the site, and we connect that directly into, say, a Mark 6E controller. That gives us kind of unique abilities to harness information off of a turbine or a system that you may not be able to get off of a standard historian with OPC type connections. But again, the centralization of data on site makes this easier. There's also solutions that are able to kind of multiplex these data sources back in. So dream as big as you can in terms of sensor technologies, and it's often about how do you just centralize all those connections back into one place.
All right, thanks, guys. And I know around the industry, there's a lot of buzz around artificial intelligence or AI and machine learning and things like that. Here's a question that asks, what different AI or machine learning techniques are used for predictive analytics?
Another very good question. My friend, you guys are engineers. As simple as linear regression, I'll start there because that's where I started when I started in my career again. But as complex as neural networks, VBMs, SVMs, deep learning models, image analytics. Now we are also playing with LLMs. I wouldn't say that we have put something in production with that, but we are evaluating that. But we have significant number of uh, algorithm packages that are being used, both from not just the AI ML, but also from the physics space. There is one more question, Aaron, I would like to address while we're on analytics. Yeah, we do have thermal models running, thermodynamics models. I think there's a question around performance, steam turbine. We have inbuilt, house-built GE models, which we call gas turbine performance models. That is part of the package. Plus, we have gate cycle, another very industry known tool, which helps you model your total plant, specifically your steam cycles, your bottoming cycles as well, and help you identify the losses that can be with respect to your thermodynamics specific heat losses. So all of this constitute, if you're interested, do follow up us with us, and we can specifically share some of the analytics example in this space.
Okay. And you did mention some of the thermal losses, and here's the next question in the list actually addresses that. What are your capabilities for identifying thermal performance losses in the steam cycle, such as on main turbines, condensers, feed water heaters, and cooling towers? Can you go into that a little bit more?
Yes, I can. Actually, there is a performance intelligence module as part of APM. I would highly, highly encourage this engineer to come. Please connect with us. Send us an email directly. We will be more than happy to walk you through specifically this element of our software. And we have good references where customers have been able to use this softwares on combined cycle boilers, oil-fired boilers, coal boilers to help understand the losses and recover those losses by taking some specific recommendations.
All right. The next question is, this individual would like to see an example of an issue. How was that resolved with a timeline? Is there a way that you can demonstrate that?
I don't know if we have anything right here at our fingertips. I mean, I'll speak to one that just came into my inbox this morning. And just kind of highlighting where we were helping the customer. But I'll break largely what we were able to do with these data and analytics into like kind of two spaces. One's around the predictive aspect, see things ahead of time and be able to respond to them, where it's optimal in terms of planning. So, or be able to alter operations to avoid a failure. So that's one around the predictive piece. The other piece of just being able to harness the data, it allows you to diagnose issues very, very rapidly. And so yesterday, one of our engineers, she actually sits in Atlanta with me, was supporting a site that we had detected that they are having high vibrations during startup. The site didn't reach out to us. We ended up reaching out to them with recommendations because the startup on their steam turbine was inhibited by these high vibrations. And what they found was, and this is all yesterday afternoon, they found that the machine is what we call rolling off turning gear. So it starts to spool up to about 200 RPM when turning gear speeds, on the order of 10 RPM. And what was causing this was a steam leak at a non-return valve that's generating the energy to roll the rotor off. What was occurring that resulted in the vibration was a rub when it rolled off. So it was rubbing, it's bowing the rotor, and then they go to start up, and that results in really high vibration. This is all in hours yesterday to allow them to understand what actions they need to take in order to get a clean and smooth startup. Turns out that non-return valve had foreign object in it. That, without being able to tie these couple things together, it's really difficult to go figure out. So this is an example of diagnostics that we're able to do right there on the spot within hours. What further is going on here, though, is this is with the ability to harness this data centrally and have centralized kind of engineering teams supporting, you're able to amplify the effect of what the site's able to do. It's not just what the sites can troubleshoot themselves. They've got people behind them with data looking at the same kind of problem, maybe from a different angle, to help solve it more rapidly.
Yeah, I can see how the teamwork would really be important.
And Ben, if I may add, and I want to share my screen because I do want to share a little bit of a marketing website as well, but it feeds right into the question. Yes, we do have a website. If you have not published this link, we will publish it again for you. Here is a case studies for different equipment types, which you see from industry's perspective, and different assets. So I just pulled up a very simple case study answering a very specific question that you asked on what did we see, how did we contact, and what was a little benefit of that working with our customer. I'm not going to walk through the example. I think Ben did a very good job in walking through the example, but we have several examples like this. And the key is, as we all know, with all our condition monitoring and predictive monitoring, you have to define your value for your mothership. And this is where APM comes into picture. We have a cost benefit analysis CBA module baked into every alerts so that you can capture the value that it prevented from happening so that you can demonstrate your value internally and externally. So we will be more than happy to share this website. It gives you several examples like this, and more than happy to take any questions afterwards on this site as well.
And I may touch on, there's a question later on from an individual regarding like a 10 megawatt machine, and does this make economic sense for a product like APM? And the economics depend on what that 10 megawatts is doing in terms of your revenue. So that could be responsible or critical to like an extreme amount of revenue, especially in maybe an oil and gas refinery situation, or if it's a critical asset on a combined cycle plant, or if it's critical in terms of the resilience of your plant for maybe black start capability. And so it's like absolutely 10 megawatt machine can be very, very complex technically and have high application in terms of being able to do predictive analytics. And if that asset's tied to critical nature with respect to revenue, yeah, it makes a lot of sense.
Okay, great point. Next question is about access to the data analytics modules. Can customer personnel access them and reports directly, or do the customers need to rely on GE personnel to generate the reports?
Reports can be generated by our customers directly. They don't have to depend on GE people. Those tools are built in within the software as well. But I do want to mention that a lot of our customers also lean on our services called IMS, monitoring service, for at least the beginning of the journey so that they can learn the chops, learn the software itself, and then they take it over in the period of 1 year, 6 months as they feel comfortable. But yes, you can generate your own reports.
All right. Question here about edge devices. Are any of the analytics being performed by edge devices at customer sites?
So we'll talk about M&D use case first because they do a lot of edge conversations, and then I'll talk about a little bit more broader where we are moving towards. So Ben, I'll leave it to you first on the edge side.
Yeah, I have a lot of fun debates with my team on where we apply edge. We've got that capability today, and we deploy it using, proprietary algorithms that we built, actually, in fact, many years ago for doing these, what we call edge analytics. But they have their time and place. They're really, really well suited for kind of critical, timely, high sampling rate types of data sets and functions. And so, yes, we use that. I mentioned our trip support earlier to be able to to capture that right in the moment and trigger an alarm for our engineers. We don't want to have latency of minutes to the cloud, so we trigger an edge analytic immediate notification to our engineering team. So that's an example.
Yeah. And where we are going, like definitely always there'll be a need for edge analytics. Uh, in the same way, the cloud technologies are evolving as well, right? Now, what is called streaming analytics to interrogating data as it is moving in. So the timeliness aspect that Ben touched upon can be addressed by having an ingestion pipeline that can pick up those bits that are of interest to you. So we see a lot of this moving to that model. One thing Ben will hopefully agree with me, maintaining edges and managing edges is quite complex, as you can see, and cybersecurity is even making it more difficult with one-way traffic or data diodes. So it's not that easy for maintaining those edges. So keep edge as simple as possible and move the capability where you can manage it better. So where we see technology growing is more on the streaming analytics side of the house, where we are able to run the analytics continuously and detect those same signatures that was being used by Edge in the past.
Yeah, I'll totally agree with you on the maintenance aspect of it, and I live that every day because as engineers we're always looking to improve, and so you put this edge analytic out there on the device on site, and my engineers find a way to improve the math, and so now you've got to go update the math on that site and every other site that you've done this, as opposed to just one place centrally in the cloud.
Okay. I'm going to combine a few questions because I've noticed a lot of people asking what you can monitor or what you do monitor. So one individual says, do you monitor any wind sites? Another person asked about nuclear sites. And another person asked about heat recovery steam generators and duct burners. So do you monitor all of those things?
So I would like to call out my friend Katie Honey. I think she asked for the wind turbines. I know Katie well. So Katie, as you're very aware, we do monitor wind turbines, but just not with Ben Myers. So within our portfolio, we have 12 businesses. If you want, I can switch back to that slide quickly. And everyone kind of have their own OEM model. Underlying technology is being used the same with more analytics from that specific domain. But yes, we are monitoring wind with the same technology. Nuclear team is also using APM for monitoring nuclear steam turbine generators, a lot of moving equipments as well. We work with them very closely. Steam turbine, I think I have already mentioned, both in combined cycle, oil-fired, gas-fired, concentrated solar plants, steam turbines, a lot of space covered with our technology. So the answer is absolutely yes. But with Ben, it is primarily the power generation fossil side, right? Fossil being mostly combined cycles and gas turbines.
Yeah, I was just in Schenectady a couple of weeks ago with a wind team talking about their monitoring. I mean, really impressive, like tens of thousands of assets. So almost an order of magnitude greater than the 5,000-6,000 that my team monitors today. And they're not only making plans in terms of how do they continue to create value for their existing monitored fleet, but getting ready for just more and more as we're hitting the hockey stick in terms of wind growth.
All right, thanks, guys. Question here about virtual power plants, and do you anticipate moving into the VPP space?
Very good question. Now comes very exciting stuff that world is talking about, energy transition. So, team, I think you guys have probably seen announcements from our side from Vernova software on Grid OS, and definitely working on DERMS, ADMS, DMS, EMS in that conjunction. We are partnered with our colleagues in Grid Software. We are looking to work more closely in this virtual power plant space because this will entail all of the equipments that we have just talked about just a little while ago. So absolutely, we are part of that journey. In some regards, we are leading that journey through our Grid Software business. But we have in Vernova, I think our big message is we want to transform to transition. We digitally transform to transition to this new sustainability world. And we want to be the partners for the entire power generation industry, electrification industry in that regards. So absolutely, answer is yes. More to come on that. Uh, and we are working with GridOS team on this specific BPP topic.
Okay. There's a question here about the end-to-end life cycle cost. I assume there's probably a lot of variables that will factor into this, and maybe every case is site-specific. But can you talk at all about the life cycle cost for APM?
Life cycle cost for APM. Okay, so one way I take this example is that uh, there is an investment required to have a software like APM to do what you do for your business drivers. And that entails a cost. Definitely, there's a subscription cost to it. There is a maintenance cost to it. And definitely, there's also a operations cost to our customers who are using the outputs of that software and driving the outcomes, business deliverables within their own sites. Uh, what we have seen is all three pillars has to be instituted. I cannot give you a specific number what is a life cycle cost, but what I can tell you is we have seen more and more organizations like Ben's, where our customers have their own monitoring team. They have their own management team, which is working internally with their sites. They are the change agents, they are the front lines. However, for technology, they partner with GE software, GE Vernova software, so that they can accelerate that journey. And we are getting more and more customers. So I would like to assume and believe that software does deliver a lot more value than they spend. Because life cycle cost cannot be less than your ROI. So there is an ROI. There is a lot of low-hanging fruit to go after to improve your availability, reliability, maintenance cost. And we do have some published stories through our customers, with our customers, on how to go about doing that. That's how I would respond. If I have not responded to your question correctly, be a little bit more specific, and we can get into the specifics of that.
Rahul, I may add, upfront costs in terms of connecting an asset, pretty standard and steady.
Yeah.
So you have that investment, each asset that you're adding in terms of just making the connection and setting up the flow of data. In terms of the operational cost, as you add assets, it's a very, very shallow curve, and that's something that you harness with respect to being able to pull all data back into one cloud-based source, run the same set of analytics across like an asset class or very similar analytics across an asset class, same workflows, and so on. So that curve in terms of adding analytics and your operational costs for doing so, or adding assets in your operational costs is very, very shallow.
Here's a question about, I think, connectivity. Do any of your sites use a data diode? And if so, how does that impact your data collection and ingestion?
Yeah, I think this is becoming, more and more the norm in terms of air gapping. Even though we have in place, standard firewalls with ports and services that are uniquely identified to how we connect, very secure kind of edge devices for data collection, buffering, and pushing data to the cloud. But I mentioned earlier the lines of defense, and a data diode's a good one. You want multiple lines of defense. The air gap is good. So we do that today, and what it ultimately entails in terms of what happens, it may require obviously additional hardware with respect to the data diode. We do different solutions in order to achieve like the level of service that someone needs. And what I mean by that level of service, sometimes there needs to be kind of talk back towards, in my case, if I'm talking to the Mark 6E to grab specific data sets, given like an edge analytic like we're talking about, that requires an additional set of hardware, all doable and done today pretty widely.
So Ben, I would add the engineer who has asked or the friend who has asked, guys, we connect into 106 countries today with 7,000 assets across the globe. And believe me, we have seen Data Dio since 2007. We have been with them for longest of time. Now it is a lot more discussed than it was in the past, but definitely a lot more complex. Uh, Increases the complexity in number of servers you have at site or edges you have your site, as well as for the maintenance and upkeep of addition of more tags and sensors like that. But good thing is we do have a data model. Ben supports that across the globe, and we have been doing it for several years.
Okay. I'm going to combine another couple of questions here. One is talking about the sources, and what about data from multiple sources outside of GE's assets? Are there any that you are not able to connect to? And further down, somebody asked about Yokogawa, Honeywell. Can you connect to these types of sources directly or not?
Maybe I start and just point out for you, Rahul, with our APM product from our software team, we probably connect to more non-GE assets than we do GE assets. My team obviously very focused around GE assets and where we can add the most value, especially with our engineering prowess. But with respect to a platform like APM, it's built for, well, it's built to be non-discretionary in terms of, or discriminatory in terms of OEM.
Yes. And again, a very good question. As you can see, for OT space, you got to be very flexible. If you have an ArcNet device, I'm going archaic now. We do connect to those, including our own Mark Vs. But we do use third-party integration softwares like Metricon very heavily, or our own iFix or Simplicity. So we convert these older methods or older protocols into more newer OPC, UA, DA kind of protocol to ingest data. But we do have solution that we can partner with you on how to connect into almost all of these different devices from different vendors that you'll see, including GE.
Okay. Here's a quick question about data historians. Does GE offer a data historian product?
Since 2001, my friend. That's the answer.
It's been around a while.
It is, and just to add, like we saw this need very early on. We believe we have a very robust historian product as well. In fact, Ben runs this on all his edge devices. We call that on-site monitor or OSMs, and we have how many? 950 OSMs now across the globe running that are streaming data back into our cloud. So that's our model. But Historian is a very established product through GE software, Vernova software, and we are in heavy duty industry, car industry, you name it, food and beverage industry, so on and so forth. So it's been used by several of our customers.
All right, very good. We're coming up on the top of the hour, so it does not look like we're going to get through all the questions, but as I said, we will answer via email following the presentation to any that we didn't get to. I think we've got time for a couple more maybe. How much time is needed in order to get insights, and what are the prerequisites to start?
Yeah, we do monitor this KPI. We call it time to live. And what we are pushing it to, and it depends on the complexity and readiness well, but we are pushing it to 12 weeks, 16 weeks time frame from start of the engagement to getting insights on your specific assets. This include data connectivity, setting up of a tenant, deploying the models, training the models, and then getting the insights as well. Some assets go faster if you have a good data collection. Some assets do go slower, but that's a KPI we are always looking to push down. Our goal is to get into 4 weeks, 8 weeks kind of time frame, but today we sit at around 16, 18 weeks kind of a time frame.
All right. One last one here. Can the predictive models be built by the customer team on UI?
Answer is yes. You can bring your own analytics. That is what I was trying to say when you asked the right question. You can bring your own models. If you're a Python shop, you can drop those models as well. And if you want to bring your own or make your own predictivity models using a software, Smart Signal software, Do you have something called Blueprint Center where you can develop the model, deploy that using the tools that are available to you. You don't have to engage GE, and use that in production environment.
And actually, I'm going to ask one more because I think this will be a quick answer. Is the historian able to provide API to connect to a customer's own system?
Answer is yes.
Okay. Very good. Gentlemen, thank you so much for your time. Do you have any last words you want to leave the audience with before we wrap up the webinar?
Just appreciative of everybody taking the time with us.
Yes, thank you very much. Really good questions, and keep it coming. Makes us better engineers.
All right. So as I said, we will answer the questions that we didn't get to, and there are still several in the queue, but we will answer those via email. And again, I want to thank GE Vernova for underwriting today's program. I think Rahul, Ben, you guys did a great job. A lot of great information was presented, so thank you for that. We hope everybody that attended found the presentation beneficial, and I hope you have a great rest of your day.
Thanks, Aaron.
Thank you.